The concept of an atom is a very important one in chemistry. In fact, atomic theory is the central theory of chemistry. So we begin now trying to imagine what an atom is. It has to have all the properties and characteristics to make it unique, so that we will understand why matter behaves the way it does in terms of what the atom is made of. The first idea of an atom came from the early Greeks. The fellow's name was Democritus, and he began to consider matter. And he considered something like this, where I have here a folder, and I open that up, and inside of that is another folder. And I open that up, and inside of that's another folder. Open that up, another folder. Finally, I get down to what seems to be the last folder. I can no longer go any smaller. And so Democritus considered matter and cutting it down until the smallest possible division of matter in which it was still the particular element that it was. And so what we have here then is the fact that matter is discontinuous. In other words, discrete particles, and you come to a particle that is the smallest possible piece that is still that element and still that atom. And you cannot go any smaller than that. And so we say that matter is discontinuous and contains discrete particles. And these particles, Democritus called atoms. An atom is the smallest part of an element in which it has all of the properties of the element. So we have that the fact that the atom is the name of the smallest particle of any bit of matter. But we do not yet know any of the properties of matter. John Dalton then kind of formalized the first atomic theory. And his idea of an atom was that it was sort of like each element had its own atom, and they would be different colors. For instance, here would be an atom of one kind of element, here would be another one. They'd be different sizes, but each one was kind of like a billiard ball or a marble. And you would have, these would be the atoms of different elements. 4 different elements represented by 4 different colors. It's kind of interesting, though. I don't think John Dalton would have used colors because he himself was colorblind. And in fact, there is the Dalton is a unit of measure and degree of color blindness. So he's that sort of thing. Well, let's take a look a little bit at what John Dalton might have been like. He was an English chemist, a school teacher, and he lived from 1766 to 1844. And there you have the image of John Dalton. His life was very interesting. He never married, and he was devoted to teaching chemistry. He had a scheme for the elements, and what you see, his first drawings of each symbol represents an atom of a different kind of element. So he recognized that each element was built up of atoms, but somehow each atom was different. And we did not know exactly how or why, but that's what the atomic theory has to show for us. The very next interesting thing that happened in the matter, or in this history of atoms, is that we came upon radioactivity. Now, radioactivity is a spontaneous breakup of an atom. It breaks up into parts and pieces. It's very interesting if you think you have an atom that's like a marble or a billiard ball, and all of a sudden it breaks up, and you find it's not a single unit. It's made up of particles. And so the radioactivity showed that to us. We started working with these particles, and we soon discovered that the atom is made up of 3 particles: the proton, the neutron, and the electron. And so an English chemist, again, his name was J.J. Thomson, he discovered the electron. You might look at that. He worked with cathode ray tubes and got this beam of electrons coming across there, and he was able to determine the charge to mass ratio of the electron. So this discovery of the electron by J.J. Thomson led him to speculate that the atom was kind of like plum pudding. And this is kind of an image or a picture of what J.J. Thomson's atom looked like. It's the sphere, sort of like Dalton, but now it has negative particles stuck into kind of a positive mass. And or the negative particles are kind of like plum pudding. And that's J.J. Thomson's idea of electron. Well, with this discovery of spontaneous radioactivity, we've all of a sudden got an idea in which we can use one of these little particles from a split atom as a bullet. And so Ernest Rutherford is the person who was able to use these small pieces from radioactivity to fire at the atom and see how they scattered. And there's a lot of studies, but here's an example. Here's a heavy element that's spontaneously radioactive. It breaks down and forms a particle called the alpha particle. It's +2 charge. And then there's protons and beta particles and neutrons, other things. But looking at, he used the alpha particle to collimate a beam of these positive particles, and he shot it at a very thin piece of gold foil. Well, he was amazed at what happened. Most of the alpha particles went straight through the foil, as if there's nothing there. So that led him to think that the atom was probably mostly space. But on an occasion, one of the alpha particle would come flying almost straight back at it, like it hit something huge and massive and positive charge, and it was repelled back directly to him. So by studying the scattering of alpha particles, he was able to conclude, in fact, from his gold foil experiment, he was able to conclude that the atom had a very compact, heavy nucleus, and with a very small negative electrons circling around it. Rutherford's contribution to the idea of the atom is called the nuclear atom or the planetary atom. And it looks sort of like, all the mass is in the nucleus. It scattered that, and it looks sort of like this concept. This is the Rutherford atom, called the nuclear atom because it has a very compact, heavy nucleus, lots of space, and you can see the space here, the distance. The mass of the electron is only 1/2000th of the mass of the proton. So very light particle in orbit, lots of space between the nucleus and the electron orbits. And the massive nucleus in it is called the nuclear atom. This is then the particular atom that we're going to study for the most. We have to now conclude for ourselves that the atom is really made up of protons, neutrons, and electrons, and we now have a good idea where they are located. The protons and the neutrons are in the nucleus of the atom, and the small light electrons, the negative charged particle, is traveling around the outside. The makeup of the atoms is explained here in this slide. The protons are positively charged, and they have a mass of 1.0073 AMU. That's atomic mass units. It's a very small quantity, but so we just approximately say that it has a mass of 1 AMU. The neutrons are neutral charge, and they have a mass of approximately 1 also. And the electrons are negatively charged, and their mass is only 0.00055, and we estimate it to just say it has 0 mass. But you must realize the electron does have mass, but it's very light. The difference, in fact, between one kind of atom and the other is really the number of particles that it has put together. So a most important idea now is that the number of protons determines what kind of element it is. And for instance, hydrogen has 1 proton, and helium has 2 protons, and lithium has 3. And we could continue down the list of elements and arrange them in order according to number of protons. And this particular thing is what Dmitri Mendeleev did. Let's take a look at Dmitri Mendeleev. This is an interesting slide because it shows that Dmitri Mendeleev was a Russian scientist, and his first idea was to arrange the elements in order of mass, and so he produced what we would call the first periodic table. The periodic table is going to be your important key, and you'll be always able to look at your periodic table to obtain answers. It's the first important key to understanding what the atom is made of and how it behaves. Here's an example of his first table. It's a little hard to read, but it gives you an idea that he's beginning to list the elements in order. Okay? It's in 1872, the periodic table, and there were some spaces he left, and later we discovered elements that belong there. So he's a very important person in the organization of the elements of chemistry into the periodic table. So let's begin to look at a periodic table, see if we can understand these concepts. The number of protons defines the element. All atoms of one kind of element have the same number of protons. If an atom has an equal number of electrons as protons, then it's neutral. Electron is negative, proton is positive. So a neutral atom has equal number of electrons and equal number of protons. So in the periodic table, we have, if you look here at this slide, we have a sample of the periodic table. And you'll notice the periodic table has 7 rows. 1, 2, 3, 4, 5, 6, 7. And it has, if you count across, it has 18 columns. And the periodic table has this number right here, 1, and then 2, and then 3, 4. You can see the sequence of numbers. This particular number is called the atomic number. And the atomic number is the number of protons. So you can see the arrangement of the periodic table. So reminder again, there are 7 rows, 18 columns in the periodic table, and they're arranged in order of atomic number. Let's take the periodic table and isolate one single element. I've chosen sodium, whose symbol is Na, sodium. And if we look at the periodic table for sodium, we'll find this kind of symbol. It has its atomic number up here, 11, and it has 22.99 down here. So we have to identify these numbers that are on the periodic chart. 1 is the atomic number, the number of protons, and down here is the atomic mass. It's not exactly a whole number because it's a weighted average of the natural isotope. But at any rate, if the proton weighs 1 approximately, we'll say then that it's contributing 11 to this number, almost 23. And if we're able to subtract 23 minus 11, we'll see that this has 12 neutrons. I'll go over that a little bit more later. An isotope is the same element, but the atom slightly differs in mass due to having a different number of neutrons. Okay? One of the things that we often do is we write an element in a certain way. An element always has the same number of protons. For instance, in carbon, there are 2 isotopes of carbon, carbon 12, carbon 14. and these are isotopic numbers. And the only difference between carbon-12, 14 is that they have different number of neutrons. All carbon has 12 protons. So isotopes are the same element but differ in the number in the mass, and that's due to the number of neutrons in the nucleus. So let's look at a symbol. Basically, a symbol would look like this. This symbol U means it's uranium. That's the symbol for uranium. 238 is its mass number, given the letter A. It's the isotope 238, uranium-238, and this 92 is the atomic number. So what we can do is we know that the number of protons contributing a mass of 1 is 92. If we take the total mass, which is going to be the protons plus the neutrons, and we subtract that, we'll say 238 minus 92. We'll see then, in fact, that uranium is an element that has 146 neutrons in its nucleus. So what we are expected to do in this concept of the atom is to be able to look at the periodic chart and identify how many protons an element has, how many electrons, how many neutrons. And I'm going to maybe give you an example from the, and write that on the board. Okay? Let's take the element, let's do carbon. And when I look at carbon on the periodic table, I find that carbon has atomic number 6, and the isotope is, weight of it is 12. So I'm going to write it in the isotopic things. Here's the normal isotope of carbon. Now we say that carbon has 6 protons. And then it has 12 for its mass number. Now with 12 for the mass number, then that means that the neutrons are adding to that. So if I take 12 minus 6, I get 6. And so I say that that has 6 neutrons. That's generally the way it is for the lighter elements. They have equal number of protons and neutrons. What I now need to do is I need to do another element for you. I'm going to take chlorine, and again we'll say that chlorine has its atomic number, and I'm looking over here to the periodic chart. It's 17, and we'll say 35. Mass number of 35, atomic number of 17, so we've got 17 protons, and then 17 minus 35, 18 neutrons. Okay. How many electrons does it have? How many electrons? Well, we know that if it's neutral, that we have the same number of protons and electrons. So we could write up above here that we have 17 electrons. Now, chlorine very often forms an ion, which is a charged particle. And one of the common ions is Cl minus. And so it would have the same number there. But what happened? How did I get a negative charge? Well, I can't change the number of protons. They're positive. But what I can change is the number of electrons. And so for a chlorine atom to obtain a negative charge, it has to pick up an extra electron. So the negative means that I got to add an electron. So for the chlorine ion, or the chloride, I'll have 18 electrons, which are negative, and 17 protons, which are positive, and netting a -1 charge, which we show up here. So negative ions, you have to take the number of electrons that exist and add in some more electrons. If you have -2, like oxygen, you have 2 extra electrons. Positive ions is the opposite. Like the sodium one that we looked at, sodium normally has 11 protons, 11 electrons, but very common ion is the sodium plus ion, which would indicate instead of 11 electrons, it has 1 less. So sodium positive ion has 11 protons, but only 10 electrons. Gaining a net positive charge. So that's how we deal with elements. So the object of this particular lesson is that we should be able to look at a periodic chart and identify the number of protons, electrons, and neutrons. The only problem I see right now is that you don't have the exact mass number, because the number that's on the periodic chart is kind of the weighted average. So what you really do is you just look at the atomic weight that's given on the periodic chart and you round it up and call that the mass number, unless you're told specifically which isotope that you have. So understanding the atom, more about the atom will come later, because it's really the arrangement of the electrons that's going to determine the properties and how atoms react to form chemical compounds. So this particular video today is for you to understand what an atom is made up and how we've defined it, and how we will continue probably to expand and make atomic theory explain why atoms cause matter to have the properties that it has. So thank you.